Now, you might be thinking that the challenges we've done so far have been somewhat contrived. Well, actually, they are all inspired from real-world problems that I've needed to solve myself. But let me show you a few more simple examples of ways in which I've used LINQ pipelines to solve problems in my day-to-day work. And maybe these will give you some ideas for how you can put them to use in your own context. Now, one great use for LINQ is that it can help you to search within text files really easily. So in this example, I'm going to show you some code that can search through the diagnostic logs for an application I wrote. And in fact, these logs are from a website I created for a product called Skype Voice Changer, which you'll know all about if you've watched my Pluralsight course on creating and selling a digital product. And these log files are actually stored in Windows Azure in what's called a blob container. So the first thing I needed to do was download them locally so that I didn't need to keep downloading them every time I wanted to search them and query them. And so you can see here, I'm showing the code that performs this download, which uses just a little bit of LINQ. Basically, I've used the Azure SDK to create a reference to the Azure Blob Diagnostics container that's got my log files in it. And then I call list blobs to get all the log files in that container with a specific prefix. So here I'm getting all the logs for February 2015. By the way, don't worry if this Azure code makes no sense to you. We're really focusing on the LINQ here. And so you can see I'm now using the of-type LINQ extension method, which is really useful, and it will check every element in the source collection to see if it's an instance of a specific type. And I need cloud block blobs in this instance. And so if the element is a cloud block blob, then it will cast it to that type, and if it's not, it will simply filter it out. Then I have a select node that creates the local file name that we'll download this log file to. And this allows us in the next step in our pipeline to use a where clause to filter out any log files I've already downloaded by checking to see whether the local file already exists. And so now, with our simple LINQ pipeline set up, we can for each through the loop of blobs and download each one of these log files that we haven't already downloaded. So now we've got all our log files downloaded locally. Let's say that we want to search for a particular phrase in the log files. Well, we can do that very easily with LINQ as well. First of all, we need to specify which folder our log files are in, and then what types of file we're searching. In this case, they're CSV files. And then what search term we're looking for. And we could use regular expressions here, although here I'm just searching for the term user submitted. And now we need to get an IEnumerable sequence of all the matching files that need to be searched. And we can do that with directory.enumerate files like this. And this returns the paths of all the CSV files in our diagnostic folder as an IEnumerable of strings. Next, we need to read all the lines from each of those files. And we can do that with the select many method we looked at earlier. And so for each file name, we can call file.readAllLines. And so now we have a huge sequence which contains every single line in every single log file in our diagnostics folder. So we need to filter this down, and we can do that by adding a where clause into our pipeline and using a regular expression to see if the line matches whatever we were searching for. And so if we run this now, and we'll use LINQPad's handy dump method to display the results, you can see that we have several matching lines. But what we don't have is any information at all about which particular log file the matches were found in and what line number they were found on. So, can we fix that? Well, yes we can, thanks to select many. Instead of just returning an IEnumerable of string from select many, let's chain a select method onto the end of file.readAllLines and transform each line into an anonymous object that contains the file name it was from, the actual line of text, and the line number. And we can do that like this, thanks to the overload of select that takes a 2-parameter lambda expression. where the second parameter is an incrementing index number, which is 0 based, and so we'll need to add 1 to it to get the line number. And of course, now we need to pick the text property of the anonymous object in the call to regex.isMatch in our where statement. And so now when we run this query, we get all the matching lines again, but for each one, thanks to the anonymous object, we have the file name, the matching line, and the line number it was found on. By the way, if we only cared about finding the first few results, we could add a call to take onto our pipeline. And that would mean it could stop trawling through all the files after we found the number of matches that we were after. So that's really useful to be able to search through text files like this. But we can actually take this idea even further. And so in the next demo, we'll see how we can use LINQ pipelines to pull even more useful information out of these log files.